Today's problem comes from the Austin P math competition in the year 2022. And we're given that this line segment AM is equal to 4 and the bottom line segment MB is equal to 9. We're also told that the plane capital M is parallel to the base of this cone, the big cone, and it asks us to find the ratio of the volume of the top part of this cone, so this short cone here, to the volume of the entire cone. And what I want to do is start us off with a square. I'm going to give this square a side length of 2, and then inside it I'm going to inscribe a square with a side length of 1. Now we know that the ratio from one side length of the big square to one side length of the small square is 2, and that's called our scale factor. And then we're going to find the area of each square. So we'll say the area of the big square is equal to 2 squared because that's the side length, which is equal to 4, and the area of the small square is equal to 1 squared because that's our side length for the small square, and that's equal to 1. And we'll notice that the area is exactly the square of our scale factor. And you might say, well, Noah, that's a square. That's why it's the scale factor times the scale factor, or the scale factor squared. But let's look at a triangle next. So say we have a triangle, and the triangle has a height of 2 and a base of 2. And then inside this smaller triangle, we can inscribe a second triangle with a height of 1 and a base of 1. The area of the bigger triangle is equal to 1/2 base times height, but that's just 1/2 times 2 times 2, and that's equal to 2. And the area of the smaller triangle is equal to 1/2 base times height, but that's just 1/2. Now we can see that the ratio between the bigger triangle and the smaller triangle is 2 over 1/2, but that's equal to 4, which is exactly the scale factor squared. And the scale factor for these two triangles is the same as the scale factor here, because the side length of one of the big triangles is 2 and the side length of the smaller triangle is 1. All right, so next we're going to look at a cube to make sure this holds in 3 dimensions. So we're going to give our cube a side length of 2 because that's what we've been working with. So we'll give it a side length of 2. And then inside this cube, we're going to inscribe another cube with side length of 1. So the volume of a cube, the volume of the bigger cube, that's going to be 2 cubed, which is 8. But the volume of the smaller cube is going to be 1 cubed, which is 1. And notice our scale factor is still 2 in this case because our side length is 2 and our side length is 1 for the smaller cube. But notice there's a relationship between 2 and 8 as well, and that being that 8 is 2 cubed. So maybe when we move to volume instead of area, because we're working in 3 dimensions, this scale factor gets cubed to give us the ratio of the bigger to the smaller, as opposed to squared. Let's look at the general formula for cones and we'll start to work towards our solution. So here we have the formula for the volume of a cone. And what we're going to do is prove that this scale factor multiplication, when we simply scale up this height and radius up or down, shifts our volume by the cube of that scale factor. So what we want to do is multiply the height and the radius by our scale factor that we'll call S. So that gives us V equals 1/3 times SH times SR all squared times pi. But now, if we simplify this down, we get 1/3 H times S squared times R squared times pi. But that's going to be the same thing as 1/3 HR squared pi times S cubed. And so you see, by multiplying our height and our radius by this scale factor, we get exactly the formula for the cone times the cube of the scale factor. So once we find the scale factor between these two cones, the smaller cone and then the overall larger cone, we can find our ratio exactly. So let's go ahead and do that. So we know that this AM length right here is equal to 4. So we know that the height of cone AM is equal to 4. Additionally, we know that MB is equal to 9, which means the height of cone, we'll call it AB, is equal to 4 plus 9. That's this short length here, that's 4, and then this big length here is 9, and that gives us 13, which means that our scale factor here is 13 over 4, with the bigger cone being on top. But that means from our previous calculation that if we cube this number, we get exactly the volume ratio between the bigger cone and the smaller cone. And that, my friends, is our final answer. I think that's enough for now.